Good morning or good afternoon or good evening, everyone, depending where you're connecting in from today. Thank you for taking time out of your busy day to come listen to us speak. Of course, today we have the guest speakers from Beacon EmbeddedWorks, and today we're going to be talking about accelerating your development of your embedded GUI on the i.MX 8M Nano SOM. So really helping you accelerate your development forward to really making it meet the needs of today's customers. So just before we get started, I just want to let you know that today's session will be recorded. And so if at any point in time you need to drop off, or maybe you have a colleague that you think would benefit from today's topic, you'll be able to have access to it and you'll be able to share the link with them and they can get access to it on demand. If you are having any audio issues, because we are streaming across the web, typically refreshing your screen resolves about 80 to 85% of those issues. Also, we have a great panel of speakers today that you'll be able to submit your live questions to at the end. So using the chat section or the Q&A section that you find on your screen, you'll be able to pose your questions to us and we'll handle those at the end of the session. Also, if you haven't, feel free to follow both Crank Software and Beacon EmbeddedWorks on social media, whether it's on Twitter, Facebook, and LinkedIn. Crank Software, we're on all three. And if you want to, you can get social with us and you can have dialogues with us. But we follow the hashtags of GUI development and Crank Storyboard. So if you have something to say and you want us to get involved, feel free to use those two hashtags. As I mentioned, today we have two guest speakers with us. Of course, I am Scott Snyder. I'm a product marketing manager here at Crank Software, and I'll be your host. But we also have from Beacon EmbeddedWorks, Russ Stebner. He is the Senior Director of Product for Beacon EmbeddedWorks, and Nick Schultz, who is a Field Applications Engineer at Crank Software. So what are we going to be covering? Well, today we're going to first jump into and give you an overview of who Beacon EmbeddedWorks is and the products that they bring to the table and how it can really help bring some power and performance to your embedded products. Next, we'll jump into introducing who Crank Software is and our GUI development tool, Storyboard. And we'll talk about how to make your embedded product more fluid to design changes, as well as how Storyboard can really help accelerate your embedded GUI development. Then we'll jump into a live demo of Storyboard and then wrap things up with your questions. So to get things started, let's pass things over to Russ Stebner.
Thanks, Scott. Let me just get my screen up here. All right, so as Scott mentioned, I'm Russ Stebner. I'm the Senior Director of Products here at Beacon EmbeddedWorks. I'm going to start by telling you basically a little bit about who we are. So Beacon EmbeddedWorks is formerly known as Logic PD. We're a full-service embedded electronics company. We have over 20 years developing system on modules or SOMs. We do standard products, we do that are off the shelf, we do full custom development, including full product development and manufacturing. Some of our quick benefits, I guess, we're US based, we have comprehensive in-house support, and we have limitless customization. We'll talk about a little bit what that means. So across the board, some of the advantages of Beacon EmbeddedWorks, we deal with more regulated industries than anything else. So we have certifications and experience to go with that. We have a lot of customers that are medical and life sciences, which means we also carry ISO 13485 certification and FDA 21 CFR 820. We have a lot of customers that are aerospace and defense. So we have AS 9100 and we're an ITAR registered facility. And some of the benefits that customers get, even if they aren't a medical life science or one of those regulated industries, we follow a rigorous testing and documentation model. So if you are ISO 13485 or if you just need additional documentation, we fully document our products, and that includes full test protocols and reports. So if you want a test report of your software, you have a starting point of what we provided you as a board support package or BSP image. So you're not having to create that from scratch. You can start from what we provide. As I mentioned, we're US based. We do all of our design, engineering, support, and manufacturing all in one facility. And we have distribution partners around the world. We're pretty well known for our small size SOMs. We have SOMs that are as small as 15 by 27 millimeter without wireless, and 15 by 33 millimeter when they do include wireless. This is substantially smaller than the other SOMs that you'll find on the market, and that's because we try to optimize for size because we have a lot of portable and battery powered applications. A lot of our competition focuses on the so-called standard form factors, things like Q7, Smart 2.0, and you're locked into what those the standard form factors are. By going with our own form factor, we can optimize for size. We can make things that will fit in a much smaller envelope than would be with a standard product. We also pride ourselves on obsolescence and lifecycle management. We really focus on having long-term available products. We always shoot for products that are available to 10 to 15 years. I have a medical customer right now that's using the exact same version of the SOM that they first started buying from us 16 years ago. In order to do that, we are pretty active in looking at the component life cycles. We are active in letting our customers know when there are changes coming to their product in terms of product change notifications and end-of-life management. We work with customers on upgrades and design changes to extend that life. We'll do consignment purchases and last time buy of components to be able to extend that life. But we don't feel like we succeed unless we hit that minimum of 10 years. So our products stick around for the long term. We also offer a wide range of temperature certifications, commercial, extended, automotive, and industrial. A lot of our applications, actually a majority of our applications are seeing industrial temperature ranges. So we make sure that we pick components and have designs that support that as well. And then I feel like one of the things we do absolutely best is customization. We don't want to just have standard off-the-shelf products. We want to make sure that we have the right fit for your end product. So we will customize our products, including part depopulations or changes, configuration options, density changes. You know, if we have a standard part that has 2 gigs of LPDDR4, but you need 4 gig, we will create a custom part to have that different density. If there's something that's included on our standard SOM and you just don't need it, don't plan to use it, we are more than willing to do part depopulation, which can save you a few dollars or remove the cost of that component. Or if something goes end of life and you weren't actually using it, we can remove that component and can continue selling the base product. So the vast majority of what we sell is customization, whether it was fully custom from the beginning, meaning we designed it to an exact end customer specification, or it has some sort of customization on top of our standard product. Kind of touched on this a little bit, but design and manufacturing, we're based in Eden Prairie, Minnesota, ISO 9001, ISO 13485, AS 9100, ITAR registered. So we're well set up for that regulated industry, and we have the manufacturing in the same facility. So when people want to know the main key factors that I recommend us or say that we differentiate ourselves from other customers, first and foremost is we do all our own hardware design. That means we do our hardware schematics, we do our layout, we do our testing on the hardware all ourselves. We do not outsource the design of our hardware. We also do all our own software design. That usually means that we start with a Linux board support package or BSP, but we do all of our own Linux driver development. We do Android, we do FreeRTOS. We don't outsource any of that software development. And then we manufacture and test our own hardware in that same building as the design team. Not only our own SMT lines, but our own test equipment that we've designed and optimized specifically for our product line. We do not outsource any of the development to third-party companies, meaning there's no even a third party for a test piece of equipment. It's all ours. And why that really matters is that if you end up having a problem with our product, there's no blame to be had, there's no fingers to point. It's our issue. We are going to work to resolve that issue with you as our customer in mind and support you through the whole step. So we know that a lot of our competition outsources one aspect. They might be a hardware design company and they outsource their software. They might even do both, but they outsource their manufacturing. And what we hear time and time again from our customers that have switched to us is that it's nice that we take responsibility for that whole thing. We take our product then, and since we've done that full design, we make it customizable. We add security features. We have that long-term life that we talked about, the small form factors. And since we have a lot of end customers that are battery powered, we do a lot of work on low power consumption as well, optimizing to try to get the minimum amount of power draw, our current draw, so that you have the long battery life. How does someone go about using a SOM? Well, typically they're going to start by buying a dev kit from us. And I have a slide where you'll see our dev kit, and then you'll actually see that during the live video as well. But the dev kit is the quick and easy way to get up and running on your product. It gives you access to that full SOM, all the peripherals, a display. You can start writing your code or developing your application around that dev kit. Eventually, you're going to take that SOM and you're going to mate it to a custom baseboard. Now, in our case, we can design that custom baseboard for you if you don't have the hardware expertise to do that, or it can be designed on your team side as well. But we mate that SOM to that custom baseboard and we put it inside your final product. So a lot of that development is happening from the day that you buy that dev kit, and you're not waiting for that custom baseboard to be developed before you can actually have a live proof of concept working of your final product. Just some highlights on our SOMs. We talked about the customization, talked about the long-term availability. With the images here, you can kind of get an idea of just how small these things are. The SOM at the top is a torpedo SOM compared to a US dime. And the bottom one is a i.MX 8M Mini and Nano, which is the one we're going to talk about a little bit more compared to the US quarter. And then that application support that we offer, whether it be hardware, whether it be software, whether it be the integration of our product into your product. We feel like we have a competitive advantage when it comes to that customization, versatility, and form factors that our competition just doesn't offer. Specific to this SOM, the i.MX 8M Mini and Nano, the dimensions on this are 28 by 38 millimeter. We support equally the 8M Mini and 8M Nano processor. These come in solo, dual, and quad core configurations. The 8M Mini in particular has Cortex A53s up to 4 core, running at up to 1.8 gigahertz. And then the little core is a Cortex M4 for your more microcontroller or real-time applications. On the Nano, the Cortex A's run up to 1.5 gigahertz, and you have an M7 as your secondary core. There's a lot of differences in the graphics capabilities between the Mini and the Nano. It's not easy to say that one is better than the other. They are just different. If you need a second USB port, you're better off with the Mini. If you need just the Cortex A cores to run as fast as possible, you're better to go with the Mini. If you care about the real-time performance, and in some cases the graphic performance, you might be better suited with the Nano. And so the difference between the processors can be a difficult decision, and our applications engineers are happy to walk through that with you and help make the right decision. Just a couple more specs. On the Mini side, currently we offer up to 8 gigabits of LPDDR4, and the Nano up to 4 gigabytes. Sorry. We also offer onboard eMMC in configurable densities and onboard quad-SPI NOR flash. By default, the SOM comes with Wi-Fi 5, which means 802.11 AC, and Bluetooth 4.2 and BLE support. On board, it has Ethernet up to gigabit speeds and includes the Mac and Phi on board. That is pretty unique that we included both those components on our SOM. It saves you a little bit of design hassle on having to have the Phi off board, saves you some space, and just makes the design easier to go right out of the box. The radios are pre-certified for FCC and ISED. We add an additional secure element on the SOM. The processor itself supports a lot of security functionality, but that additional secure element helps with enabling of end-to-end security. And then coming soon, we have an i.MX 8M Plus that's currently in development. The 8M Plus is the new SoC from NXP. It kind of takes a little bit of the best of both worlds from the Mini and the Nano, meaning the Cortex A speeds of the Mini, the M7 from the Nano, but it now runs up to 800 megahertz. And then it adds a Tensilica Hi-Fi 4 DSP and a neural processing unit, or an NPU, that's capable up to 2.3 TOPS. There are some improvements on the graphics as well. And as well, it's got a capability for encode and decode for both H.264 and H.265 for video applications. Our SOM will then be upgraded to Wi-Fi 5, we'll include Wi-Fi 5 and we'll have an upgrade to Bluetooth 5. And once again, it will be pre-certified. One of the unique things on the 8M Plus versus the Mini and Nano, especially for those of you that are doing the GUI development, is that there's a lot of display options on the 8M Plus. There's a MIPI DSI display support, 2 LVDS displays, support for HDMI with eARC. We are an HDMI licensed adapter, so our reference boards and baseboards have the complete design for HDMI, and those are things that you can get access to the schematic to implement HDMI in your end solution. So it makes a great reference design or a SOM to start the design for a multi-display application when you might have multiple GUIs going on in your application. I mentioned the dev kits. This is an example of the mini Nano dev kit. It includes everything you need to get going right out of the box. That's the baseboard, the SOM, the power supply, a micro SD card with adapter, a camera, an antenna, a card reader, and cables. It's one dev kit that supports both the mini and Nano. Right now, the ones that are in stock through distribution come with the mini SOM. Eventually, we'll have versions that will come with the Nano. But this one box will allow you to get up and running on our hardware right with one purchase. Now, if the 8M Mini, Nano, or 8M Plus don't meet your needs, I just want to mention that we have a few other things, and especially of interest to people doing GUI development. We have an RZG2 series of SOMs that's based off of the Renesas series of processors. At the low end, there is the RZG2N. At the high end, there's the G2H. The main differentiating factors of this versus the 8M Mini really is the graphics capability. Yes, they have a lot more powerful Cortex-A cores as well, but if you have really graphic intensive applications, these are probably a better fit. It is a larger SOM. It does, have other disadvantages like heat or size, but when it comes to the graphics performance, this is the best we can offer and one of the highest performing SOMs out there. It's also unique that in addition to the Wi-Fi 5 and Bluetooth 4.2 on board, we have an option for cellular on board as well with an LTE Cat M1 or narrowband IoT cellular radio on board. So the graphics is the main seller, but the cellular options certainly help as well. On the software side, Linux versions available. We have images and source available for Buildroot, Yocto. We do long-term support or LTS versions of Linux. We also take custom requests. So if a customer has an exact version that they want for whatever reason, or if they have a certain build option they're looking for, we're happy to help support our customers on that. Most recently, we had a customer that required Ubuntu, and we did a specific version for their request. But we have BSPs for Android, FreeRTOS, and many others. And then the last thing I was going to talk about is our support. It's not just buy our product and figure it out on your own. We have online resources, including a technical support forum where there's a discussion board and there's access to lots and lots of documentation, both on the hardware and software side, but basically all the technical files you could possibly need. That means board support packages, the images, the boot images, virtual machines, user manuals and release notes, application notes, the schematics and layout of our dev kit design, and then our FCC and ISED certification data and the emission scans. We also have direct support options available through our applications engineering team. Our applications engineers are all both hardware and software engineers, so we don't have to pass you around from one person to the next. You have a question about our product, you get associated with one applications engineer, and they're going to support you no matter what that need is. If it's a small amount of hours or a short-term type of request, we're happy to help you for free. If there's something that's more long-term or dedicated specific to your product, we also offer support contracts. Those typically come in 40 and 80-hour paid contracts that we will do whatever it is you need. Some common examples would be driver development. You have a peripheral or component on the rest of your system that you want a Linux driver created for. We can create that driver for you. If you wanted a schematic review of the rest of your design and want to know how to integrate our SOM into that design, they will review your entire schematic and look at common pain points or potential issues to try to eliminate that. And what we find is that this frequently leads to a reduction in the number of board spins that happen on the customer's end product. And then another one specifically for GUI development, we get a lot of requests for specific LCD integrations. People come to us and say, we have this exact touchscreen, or LCD, it's this resolution and this brand, and we just want a driver for it to work right out of the box, and we're happy to help with that as well. So no matter what your request is on the support side, even through that full application development, we're a full embedded solutions company, and we can handle all of that. So that's kind of us in the briefest of nutshells possible, covering what we do at Beacon EmbeddedWorks. And I'm going to pass it back to Scott, and he's going to start talking a little bit more specifically about Crank.
Perfect. Thanks, Russ. So when it comes to developing GUIs for today's embedded products, we know that things have become increasingly more challenging. User expectations have been elevated. Definitely today's consumers expect an intuitive and modern touch experience, not only for the physical hardware of the screen, but the quality and smoothness or the experience that they have with that product, in particular with its graphical user interface. Definitely the user interface is a defining part of today's products, with its UI being one of the main factors that is being measured upon, and it really drives the value that consumers see in the product, no matter what industry they may be in. Definitely, integrating evolutions in technology also no longer means making hardware decisions anymore. That still plays into it, but even more so is how can these technological advancements be incorporated into the user interface? And then, of course, any time lost or any time resources are wasted, or due to coding changes that need to occur, this all creates delays in getting the product to market on time and on budget. So in terms of the UI or UX for devices, definitely the overall user experience of a product is not just about the functional aspects, but rather it taps into the emotional attachment that consumers have with the product. For a well-defined product is not only perceived to work better, but is simply seen as better than other products that are in its category. Also, it makes the users feel good about using the product, which ultimately leads to really building brand loyalty for that product. And so that while some of the design issues may be related to a limited understanding of how users intend to use the product, most of it comes back to the inability to make changes to the UI in a timely fashion, which we're going to address in today's webinar. So if you haven't heard of Crank software before this presentation, I can guarantee that you probably have used a product that is running a UI that was built using our UI development software, Storyboard. Our technology was created to help make GUI development more efficient for embedded platforms all across markets, like traditional markets like medical, automotive, or industrial, or consumer markets like white goods, IoT devices, and wearable devices. Crank Software is a software and services company, which means that not only do we create Storyboard or software, but we have a team of application specialists in-house that can help you out with your product. So if you are looking for a quick prototype, or maybe perhaps you have the resources but not the time, or maybe you don't have the resources, we can be there to help you out, to really help move your project along, to make sure that you meet the time commitments that were given to you. So Crank Software is headquartered in Ottawa, Ontario, Canada, and was founded in 2007 with a leadership team with an extensive background in embedded software system and graphics. Our product Storyboard has been used in products across the globe, including small organizations all the way up to Fortune 500 companies. We've received numerous awards and been recognized for our software, and more importantly, so have our customers that have used it to develop the GUIs for their products. With millions of devices active in the field today, we are shaping the next generation of embedded user interfaces for embedded products. So like I was saying, the founders of Crank Software set out to build a solution that could really help remove the inefficiencies that frustrated them and, of course, their developer colleagues when it came to developing GUIs for embedded devices. So based upon over 2 decades of experience in designing and implementing embedded GUI solutions, like I said, for a broad range of industries, Storyboard was really designed to remove those barriers or those issues that are typically associated with UI design and development. and it really provides a foundation for accelerated and streamlined GUI development for embedded products that allows both UI developers and designers to work together in a collaborative workflow. So powerfully simple yet sophisticated is what we hear often from our customers. Its easy use interface enables them to create GUIs more quickly and more efficiently, really enabling them to get to market faster. So by decoupling the front-end UI from the back-end logic with a well-defined kind of API in between, Storyboard makes it easy to get started early on the GUI development, and it helps to really allow you to embrace design iterations that naturally occur and reduces the complexity of developing GUI solutions for an ever-evolving embedded hardware market. And so let's jump into exactly how that's done. So all before the final hardware decisions have even been made, you can get started on the UI development in familiar UI design tools such as Photoshop or Sketch. And when those files are ready from your design team, they can easily be imported into Storyboard where they become the building blocks of that UI. And from there, the UIs can be brought to life using Storyboard's integrated animation tools, allowing you to create, edit, and review animations all directly within Storyboard, as well as any critical UI flow and usability testing can all be performed within the tool using its integrated prototype and simulation functionality. Again, all without requiring those final hardware decisions to be made or having to even deploy the UI to the actual hardware to get that UI being developed. Of course, as we like to say, the quicker you can get it to hardware, the sooner you'll be able to figure out how it performs on the hardware. And from there, the UI can be exported out into a mobile device for a portable hands-on experience testing or to show stakeholders and obtain their feedback, and then move it on to really kind of the next stage, which is doesn't matter who it is or when it is, once design begins, there's going to be some changes that need to occur, and all this can be easily done without impacting the development progress or causing a complete teardown of code. So it allows you to introduce design changes that completely modify maybe the look of the UI, or maybe just make minor changes of moving a button here, changing the color, maybe changing the font, simply by going back into the design files within Photoshop and Sketch and re-importing those design files into the application without having to create an entirely new application or overriding prior development efforts. So more importantly, we have a unique thing called compare and merge, which allows you to remain in control of those iterations through which you can see what was there and what's being imported, and you can choose which change content you wish to accept and deploy within the UI before committing those changes to the final design, really allowing for a more efficient and collaborative workflow, and particularly when you have multiple people that may be part of that whole development process. And more importantly, is that any actions or events like Nick's going to show you in a moment that you've created remain in place and are attached to those new assets, those new updated assets. And then, of course, you can use the actual insight that you can gain from Storyboard's tools to develop, to really kind of within your development process and really allow you to kind of fine tune the performance and optimization of it to really give you the confidence that your UI is going to perform as optimized as possible when you deploy to your actual target hardware. Of course, last but not least, even with a vast choice of hardware and operating system combinations that are out there and that you may need, it's highly likely that Storyboard UIs can run on it, because Storyboard was created to be platform agnostic, so they really help you de-risk your embedded device project by introducing a framework that easily supports technology and design changes at any point in the development cycle, really allowing for a broad range of GUI flexibility, such as scalability, allowing you to scale up or down across MCUs or MPUs, portability, so really allowing you to adapt to changes in your technology stack. So for example, maybe you start off with the 8M Nano, But then when the 8M Plus gets released, you may feel that maybe this is best suited for my project. Well, you can easily swap out the hardware for it without really kind of having to throw away your GUI and then restarting it. Because what we do is we use runtimes, and we have runtimes that have been optimized for that hardware that allows you for that portability. And then last but not least, we got reusability, which allows you to take older projects and allow you to kind of like move it across the different hardware, or to dust it off and kind of put it onto the new hardware. So maybe if you have a multiple product lines from low end to high end, it allows you to have that consistent look, touch, and feel simply by reusing the UI from older projects or other projects. So really, what makes Storyboard different? Well, Storyboard was designed, like I said, to remove those barriers or issues that are typically associated with UI design and development. So it was purpose-built for collaboration around UX, really, to help developers and designers to work together to iterate with ease in the quest for the optimal user experience for that GUI application. Like I said, it also has that distinct separation of design and code environments. So you have that front-end design is decoupled from the back-end logic, really enabling developers and designers to update and test the app at the same time in parallel without destroying the work or necessitating any extra work to be done. We also have our rapid design iteration and re-import technology, which allows you to take those design files from whether it's Photoshop or Sketch and to import it or re-import the updated Sketch files or PSD files with all actions or events that were previously established being reattached to the changed ones. And then we have that graphical compare merge tool, like I said, that allows you to remain in control of which changed content you wish to accept and deploy. And then finally, we have that platform and OS independency. So really allowing you to develop your GUIs once, deploy them often, or allowing you to deploy across different hardware by simply applying the appropriate runtime, allowing you to maybe move from maybe it's the Nano SOM to maybe one of the Renaissance SOMs that Beacon EmbeddedWorks has. So you've heard me talk about it. Let's jump into actually showing you it, but I'm going to hand things over to Nick, and Nick is going to take you through a run through the actual software itself.
Perfect. Well, thank you very much for the setup, guys. Great information from Russ and you as well, Scott. Alrighty. So what I always like to do before jumping into Storyboard is give you guys a quick preview of what we're going to be working with today. And everything starts off in Storyboard, with a concept, right? Our tool is all about, maximizing the workflow, how you add interactivity and behavior to your UI design. And, in most cases, I'm not going to say it's 100% of the time, but in most cases that starts off in a design tool like Photoshop. Photoshop, sort of been around for a while, kind of the king of raster graphics. So we support a direct import from this tool, as well as tools like Sketch. And then there's also ways that you can, take content from something like Illustrator, maybe in vector form, and bring it in via Photoshop. But what we really want to showcase, and by no means am I a graphical designer here, I'm not going to teach you anything revolutionary, but we want to show you that if you apply some thought and some layout and organization to your design, you can import that directly, preserve all the hierarchy, and then just hit the ground running and start adding implementation. So what I've got here is a smart home control. It's starting to be a little bit more common where we get these all-in-one devices where you could imagine this being a wall panel where we've got our thermostat control, some settings for weather. So maybe this is a network feed, or maybe even you have a sort of portable weather system outside of your home, giving live data from your location. And then some settings pages for internationalization, measurement units, voice integration, since that's becoming all the more pervasive these days, and security finally. So this is sort of a good building block. It's a high fidelity design. It's not just wireframes. There's been some look, some feel put into it. as well as there's been a little bit of organization set up. So what you've seen here as I've scrolled over is we have 6 screens is what we'll call them. And a screen is going to be what's visible when you're running the application at any given time. So, you know, the thermostat screen or the weather screen, setting screen, etc. And a storyboard application will be made up of one-to-many screens. And each screen is then made up of one-to-many layers. And layers are groupings of like elements. So you see I toggled visibility of the menu controls and the logo there, similar to thermostat content, you know, the display, the buttons, and then finally background. So these are all sort of groupings of content that, you know, makes sort of logical sense. And you can then mix and match these. You can share them across screens. So things like your background and your menu layer, based on the name there, you know, being, you know, unique names. And then we'll see that repeating there. You know, the tool will realize it's a single definition and instance that across your application. So again, design once, reuse many. Within a layer is where we have elements that are, you know, we'll call controls. And this is where controls are basically the main element for rendering content to a display. So, you know, a control will have, you know, like anything in computer graphics, a width, a height, an X and a Y, so representing a rectangular space. And then it'll contain content like images, text, you know, solid colors, arcs, even 3D elements if you'd like. And you will, you know, mix and match them to create the effects that you'd like. And you can see here, as we're going through, we have this mode control element there, where it's, you know, some text with an underline. That's, in this case, a combination of text and graphic, so you can mix and match. And then in some cases where you see this underscore up, underscore down, we're going to bootstrap that interaction into a button for you during import. So all of that just to give you a quick overview of what we're actually doing. You know, this isn't any, you know, special things that, you know, we do in-house. These are, you know, tools that the design folks in the world use every day and can be imported into the tool. So just some naming, some organization, and you're ready to hit the ground running. So go ahead, close Photoshop down here. Perfect. And there we go. We will, you know, start off with Storyboard. So if you've never used Storyboard before, this is the first screen you'll get, and welcome screen that gives you some quick start links. So tutorials, documentation, our support channel. You know, so similar to what Russ was talking about earlier, support is, you know, a very, you know, important part of what we do. You know, we're out there to make our customers successful, and this is a, you know, a very important part of what we do. So you can contact support, where we offer, you know, free help to our customers, and you know, that can be done through email, phone. It's not uncommon. If it makes sense, we'll hop on a screen share as well. Also, getting started links to play around with. So close that down, and then this is the main screen you will get to. And from here, this is the you know, our environment. So it's built on top of Eclipse, which you know, means if you can run Eclipse, you can run Storyboard. You know, I spend most of my days in a Ubuntu Linux desktop, and I run Storyboard there. And it also means that the collaboration tools and integrations for Git and SVN available via the Eclipse Marketplace work directly with the product as well. So I can collaborate with users running on Mac, Windows, you know, different parts of the world, and you know, work with the very popular Git development workflows of today, where you have branches, merge them in, if need be, cherry pick changes, and collaborate in that fashion. And to kick things off, you know, there's a few ways you can go. A new empty project where you're going to, you know, specify everything yourself, your resolution, color depth, stuff like that. You could import a sample, or new project from Photoshop content. And this is where I'm going to navigate to the PSD that I used earlier today, showed you in Photoshop. select that one here. And then I'm going to go ahead and leave all these settings the same. You know, they're all just sort of manipulate how content might come in. The default settings are good for me. And we're going to select a new project. The other options, important to mention, are there for perhaps you are given 1 or 2 screens from your design team. And then as they are building up content, they will start giving you, new screens piecemeal. So you can import them into existing projects and work in a method like that. And as you saw while I was talking, the tool was reading the Photoshop file. It was parsing the naming conventions, the structure, slicing up the images for us and laying everything out the same way that we saw in our tool. And this process, I use Photoshop. Again, I mentioned we support Sketch. So if you're on a Mac, because Sketch is a Mac tool, you can then do the import. You would see a little gem icon in the toolbar beside our Photoshop icons. The layout of all the content is the same. We've organized the screens alphabetically here, so I can go ahead, select our thermostat screen, and the properties panel on the right, and then tick start screen, and that will be the first thing we see when we run and launch our application. And if I hit simulate, save, we have our application. It's running. It's built against a Windows executable runtime, as Scott mentioned. So we provide runtime environments for all of the platforms we support, and the same core code is common across all of them. So you know that these press and release actions that swap the image out for this button effect will behave the same way on your target platform, whether it's a Linux system or you're going down to the microcontroller level running with FreeRTOS, ThreadX, something like that. And that is what we do. We make this easy. We abstract away the hard platform integration and cross compilation, tool chain management, all of that. We really want to just let you focus on building your UI. So, this application, as much as it is on the desktop and it has access to my OpenGL system with the graphics card, I can do the majority of my development before hardware is even available or ready. And, in today's world of supply chain issues with silicon, I think that's an important thing where you are very decoupled from, the hardware or even the base software side. So you can build this UI up in isolation. So from there, I'll just quickly expand our content. You can see here our menus are all, sorry, not our menus, our layers are all named the same. Within them, our content is the same. So, hiding that layer, you see that thermostat content hides the same way it did in Photoshop. And I'm going to just start adding some interactivity. Everything that we do in Storyboard is event-driven, so it starts out with an event. Events, they will trigger what we call actions, and actions are the behavior. So if I, wanted to create some draggable screen transitions, it's very easy for me to do. I can right-click on our screen here, say right-click, add an action, and this is where I can start mapping up the events to the actions. And the nice thing here is we have a bunch of events that are available already, built in. You can see there's some even for Android if you wanted to export an APK, for instance, with the lifecycle. But to start off, I want to configure draggable transitions. And to do that, every time you go to a new screen, there are events that fire when you show a screen or you hide something else. So we're going to use one of those. So the screen show pre or post, so before the screen renders or after. And then we're going to look at the action, and the action there is a screen drag transition. And this is where you can configure them. So if we just start filtering down to do that, screen drag transition configure, and this is where I can select the parameters for this transition. So the type, which is similar to other ones that maybe you might bind onto a press event or something like that. I'll stick with path. We also have options for the frame rate, so I can go ahead, crank that up to 60 if we want, duration, easing curves, which you can also define your own custom ones if you'd like. Stick with linear. And then say, what direction based on swipes. So in this case, we're on the thermostat screen, and if we kind of look at that, you can see the weather and settings screen down below or to the right. So I'll just give an option to move to the right, which will be the weather screen. Say OK, and then you can see that new binding show up in our actions panel at the bottom. So associated to that screen, when we render it, we configure that transition. And for the sake of quickness, I'm going to copy this, and then I'm going to go ahead and paste it onto the weather screen and use that as our template and set up our mappings there as well. So now that we're on the weather screen, it makes sense we could go to the left for thermostat, to the right for settings. So that's where I'll go ahead, make my modifications, and I'll pick the security panel to the right. Save that. And then the last one being our security. Right click, add the action, just showing it to you again. Screenshot post, configure, and this is where we only want to do a left direction back to the weather screen. Nice and simple. Hit finish. And assuming I haven't done anything funky or misclicked when we run this, we have these nice draggable transitions. And the nice thing about this is because I've configured it and the engine is agnostic, it's going to behave the same way when you run it on a touch panel. The mouse pointer events are treated in a way that, whether it's a touch input or a pointer input, the engine handles that and translates that into the draggable events. So a couple clicks and you've got navigation set up. And you can see here, these buttons as well came in already pre-configured thanks to some just naming conventions in the design file. So now that we have the navigation set up, the next thing I always like to do is quickly build up an animation, because animations are really, the glue and the little extra something that turns a good UI into something great, a little extra interaction. And a good candidate for that is our menu on the top left. And you may have noticed we have the scrolling menu layer. It's not visible, but it's available on all the different screens here. And what's happening is we actually have a bunch of controls that are set to -290, so off screen. If I set them to 0, you can see there. So they're a really good candidate for that context menu of popping in and out. So I'll set that back there. And then with an animation, an animation is simply just the manipulation of a single property. So in our case, this X coordinate over time. And we have an animation timeline here where you can kick off, create a new animation from scratch and start picking properties you want to manipulate. But there's an even better way to do that, where we can flip this button at the top. It'll toggle an animation record mode, and then we can make changes directly to the model, and then that will bootstrap our animation timeline for us. So in this case, I'm going to go ahead and set it to 0. I'm going to close our animation recording off, and then we'll give it a new name. So I'll say menu open, set the frame rate to 60, and then select absolute values, hit OK. And you can see it reset everything in the editor, but now in our timeline, we have this menu open animation, and all of the manipulations here show up as these steps. And the tool does a best guess. By default, it'll set everything to be 500 milliseconds and linear easing curves, but that's where, maybe, if you wanted to, you can preview it here. Whoops, popped up in the other window there. So I'll reset that. You can see here, it's okay. It's the linear motion isn't necessarily a natural feel to it. So, we can go ahead and make a quick change there. Select our elements and say, an ease in, and then maybe even adjust the curve out just a little bit more. So we have our custom rate there, hit save, and now this custom rate is applied to all of our steps. Also available if we wanted to use that for easing curve on our transitions or other animations. So again, this is where you're going to do that. And you know, that's all right, but maybe we want to create a nice little staggered effect where each cell slides in one after the other. So to do that, I'm going to go ahead, deselect those, drag these elements out, and then I'll just freehand this where, you know, I know the graphic designers at Crank are probably, their ears are burning right now. They know something's going on where, you know, they could do much better than what I can. But that being said, I can create something that looks relatively nice with, you know, a few different clicks. And, you know, in past life when I've been implementing user interfaces, you know, when I would be given an animation I had to do in code or something like that, it would take a lot of trial and error. If I was lucky, I would get a video displaying what those effects look like, and then I'd have to script them out, recompile, deploy, test. It was a really time-consuming cycle. So this looks pretty good. You know, so I'm happy with that. We'll go ahead and close that and back out. Now you can see we have this animation. And this is something we can go back, we can tweak it, we can edit it later, but for now we're going to trigger it. And similar to what we've seen earlier, where, you know, events trigger actions, we're going to use this control here as our trigger point. So I'm going to right click, add an action, and instead of that screen post event, I'm going to select a touch. So this touch event, press and release on the same control. We'll do an animation, menu open. And you know, this is where we can control other parameters. Again, you know, you're selecting an option from the list here, but you could go ahead and say I want it to go to a specific point in time or even reverse it. But in this case, you know, I just want it to run, and then I'm going to tick this option. I don't want it to clean itself up because I want to be able to reverse it after the fact and sort of do that collapse effect for free. So I'll say finish. And then if we select our main menu control, this is the one with the X on it. Right click, add an action, touch, animation, menu open. Start it out at 100% complete, and then reverse, and we'll get that nice open and close effect. So if I run this, you know, we have our buttons here, we have our screen transitions, and if we select our button, we have that nice animation, and it reverses for us. And you may have noticed I only bound that to, you know, the button on the thermostat screen, but because that layer is shared, that binding applies whatever instance you're on. So again, I have that, you know, use once, deploy many type behavior here. And, you know, given where we are in time, I'm gonna cut this demo off because I'm gonna hand it back over to Russ, because he has a version that he's gonna show you running on live hardware, which is, you know, that final step. And, you know, the real beauty of what we do here is you get to fine tune the experience, and then you can pick and choose what hardware you want to run it on, or maybe even compare it across different boards. So as Scott was saying, if you started out with the Mini, but we're curious to see how the UI worked on the Nano, maybe there's certain reasons for going one way or the other, you know, you can just easily deploy it and run on all the other platforms without issue. So if I open up my panel here, stop showing my screen, this is where we'll kick it back over, and you should be able to see Russ interacting with it live on his webcam.
All right, so as Nick mentioned, this is basically that same demo. It's running on our hardware. So what you see on the right here is our 8M Mini Nano dev kit. Right where I'm pointing here is the SOM, just that little section there. But our dev kit is a full-featured baseboard to be able to run 8M Mini Nano hardware. I have a 7-inch touchscreen here, and I can interact with it and show the temperature, the weather, the security settings, and you can, you know, interact with the buttons and see the temperature setting go up and down. There is that drop-down menu that he was playing with coming in from the side. So from the time that Nick had that demo up and running, he sent us a zip file. We just downloaded that file and extracted it onto our image, and there was no other configuration or testing required. So it was extremely simple to get it running on real hardware in Storyboard, you could see a virtual or a simulation of what it was going to look like, and you can see that it comes through really well.
Perfect.
That's all I had for this. Thanks, Nick.
Perfect. Thank you. And I'll just take over, and everybody should be seeing my key takeaways just to kind of wrap things up before we get into your questions. So definitely, if you're looking to elevate your next embedded product, take a look at Beacon EmbeddedWorks, variety of different SOMs that they have available to you. One in particular, of course, is the 8M Nano, and you can find additional information within this link. Also, you can try out Storyboard for free. We have a full-featured working version that you can download, and you can use it for 30 days. Just need to contact us. We'll send out just actually go to our website to cranesoftware.com/free trial, download it. Key will be mailed to you, and you can start playing with it, and you can start seeing how you can really kind of accelerate the GUI development process for your next embedded product. So with that being said, let's jump into the Q&A session and definitely jump in and find out what it is that questions are you guys have. So let me just open up my panel here to take a look. All right, so the first one I have is, I'm working on a medical product. How do you support medical customers?
Yeah, I can take that one. Specifically on the hardware side, I mentioned that we deal with a lot with the regulated industries, and we're ISO 13485. So we provide full documentation, as I mentioned before, software test protocols, software test reports. It's an ISO 13485 manufacturing facility. And more often than not with our medical customers, what we end up doing is we create a custom part number for the hardware that they want to order, and we consider a lockdown assembly, which means that there's absolutely no chance for anything to change without their written permission. And normally, there can be things that are simple as a piece of silicon is being manufactured at one facility, now it's being manufactured at another. And as long as we're happy with it and qualify it, it's still the same assembly. On a lockdown assembly, or for a medical customer, they might want to have final say on that approval. So if it's a lockdown assembly, they'll get even the most minor of notifications, if that's what they want, to let them know that something in this device has changed. Even if it's form, fit, functional equivalent, they get those notifications to let them know that something's happening. And we work a lot more closely with the customers that have the lockdown assemblies, just to make sure that we're giving them the right level of detail they're looking for. Otherwise, it's usually mostly about the documentation, and that's what we do more than anything else is regulated. So we feel like our medical customers are pretty happy with the support they get from us.
Perfect. And from our end, typically, we do have medical customers when it comes to the GUI, but most of the heavy lifting is done by the actual hardware vendors itself with the certification. So you can easily kind of just the inputs coming in from us need to be from a secure standpoint, and that's all handled with the hardware and the chip itself. Where can I purchase the development kit?
Good question. So without giving any preference, our main distributors are Arrow, Avnet, DigiKey, and Future, including sites around the world. I will say that with the shortages of components right now, the only people that I believe have it in stock or will have it in stock shortly here is DigiKey at this moment. We do have components on order that are delayed like everything else in the hardware world, but we should be able to fulfill dev kit orders pretty quickly.
Are there any software BSPs available?
Yep, right now we have both Mini and Nano. We have Linux and Android. We have a couple custom options as well, like I mentioned, the Ubuntu, and we have FreeRTOS. But Linux and Android are actually available on our support site. Typically, what happens is you would buy a dev kit and you would sign up for an account on our support site. We just verify that you actually have the hardware. And that there's no export concerns with what where you are in the world, and then you get access to the files specifically for that product.
Perfect. Next one is, does the generated project take advantage of the GPU, or does it run only the A cores?
I'll grab this one. Absolutely. So if there's graphics capabilities available on the hardware, that's what we leverage to help improve performance. And on a system like the i.MX 8 or even the Renaissance boards, we've got multiple high performance cores and graphics. This may not be something as noticeable, but as you scale down to the MCU space where it's maybe a single M core, a couple hundred megahertz, anything you can use to offload that CPU and improve performance is huge. So, part of what we provide for a runtime perspective when you are running on those platforms is integration to the hardware accelerators, and certainly making sure that there's optimizations for the board and everything is up to snuff from our point of view. So yes, whether it be 3D, 2D accelerators, that's part of what we do and how we help get the best performance from a graphical standpoint on embedded hardware.
Perfect. Now then, do I need to use a design tool to build a GUI application with Storyboard?
No, you certainly don't. So, earlier I mentioned, most designs or ideas start out in a design tool, but it is very possible that you are working on a product line that has images and icons already available. So, in those cases, you may not be coming from a fully, high fidelity Photoshop or Sketch file. You might just have a pack of assets and some sketches or diagrams, and you import them directly into the tool. You can build screens, layers, controls manually. Similar to how I added the event bindings, it's right-click, add screen, right-click, add layer, control, etc. So you can certainly build it up free-form as well.
Another one that kind of goes hand in hand with this, when re-importing a PSD file, what kinds of changes are likely to break things?
Oh, great question. And this is where, given the shortness of the demo, we only showcased a little bit, but what I was showing while we were looking at the file in Photoshop is the naming convention is very important, and that's where we read the structure. We'll look at the naming conventions, the names for layers and controls, and then we'll use that as a main guide. There's also some logic that happens behind the scenes where, if the control itself, the sizes of it change, we need to be aware of that so we can adjust it. But generally speaking, if you don't change the base structure that much, then the re-import will replace the content, reposition the assets, swap out the images, all of that good stuff. And then as you add new content, that will just show up alongside it. Now, if you do something where you perhaps change a control, the name of it, but the content is the same, we have some fuzzy logic in there to try and detect that, and it'll flag it during the re-import and say, is this something you'd like to consolidate? So you can then select them and consolidate them, or maybe it isn't something you want to consolidate, so you can then choose to allow it to treat as separate. So generally speaking, the closer you are to following the naming convention that's in your project and from the original file, the more seamless it'll go. If you diverge, and let's be honest, that happens during development, that's where the tool will start showing you new content versus old and allow you to mix and match, pair, merge, ignore, etc. So very much a merge conflict style workflow, but in a graphical sense.
Perfect. Is it possible to automate, extend, change generated model with some API later, such as an SDK, C, C++, Python?
Yeah, there's a lot of stuff you can do, and I'll take a guess here. And when you say automate, I think this tends to go into continuous integration and testing discussions. And certainly, we provide the ability to export a model file and project from a command line interface, so you could integrate it into your CI systems, as well as there are there are hooks that allow you to inject events into a running application if you need to go down a testing route as well. And that's what we do internally when we're validating our our engine as we're adding new features, fixing bugs. Internally we have regression testing that runs and deploys test applications on all of our supported hardware platforms in a lab. So, we know that changes we make to the engine run, properly on the tested hardware, and then those results are collected and verified by our integration system. So, there's certainly plenty of hooks available for automated testing, and that's where, each end customer has their own unique test environment, and that's where, we're a very open tool and we fit very well into those spots.
Perfect. Do you have a SOM for AI or artificial intelligence or machine learning applications?
I'll take that one. So yes and no. I mean, there's plenty you can do with just the Cortex A's or the GPUs of what we currently have available. That 8M Plus that I mentioned is coming soon would be the first one that is really targeting artificial intelligence and machine learning. NXP is including that the NPU, or the neural processing unit, with 2.3 TOPS capability. So that'll be the first one that's like its main purpose in life, is to add AI capabilities. With that said, both 8M Mini and our RZG2 series, there's plenty of machine learning type applications that are, running TensorFlow or what have you on those SOMs. But the 8M Plus would be the first one that would be targeting that specific market.
Perfect, thanks. And final question is, how do you manage or handle different types of inputs or connections? And I think that may be referring to the front end, back end decoupling that we talked about.
Sorry, Scott, repeat that for me. It cut out a little bit.
Yeah, sorry. How do you manage or handle different types of inputs or connections?
Oh, okay, perfect. And yeah, that's great. Great question. And what we do is, especially because we run on such a wide variety of systems, there's lots of different types of input that you could get. So we provide a C library that's called Storyboard IO that allows you to inject events with data into your running application. So the GUI will run as its own task or process, depending on MCU, MPU. And then this library, which you can include into your what we'll call backend code, gives you that connection. So you can then send and receive events and data to and from the UI. It's very similar to sort of a message queue style semantic, and it's a agnostic library where, again, we handle the integration onto each platform. So if you're still up in the air about maybe what OS you want to use, you write the same Storyboard IOC code and have a much more portable solution.
Perfect. And so that was the last question. So thank you very much for everybody taking time out of your busy day. I know we all have a lot going on in our lives these days, but thank you for coming out and to joining us to listen to both Beacon EmbeddedWorks and Crank Software talk about how using the two together can really help accelerate your next embedded project.